Hey everybody. So in this lesson, we're going to be learning a little bit about creatine. Now, creatine is you're probably familiar with it as a dietary supplement. It's something that people will typically take as a part of like a a bodybuilding regimen and a bodybuilding kind of supplementation protocol and procedure. Now, with that said, creatine is classified as a molecule that is an amino acid. Now, we've talked about amino acids previously, and specifically, when we talked about amino acids, we talked about them as building blocks of proteins. Now, creatine, and this term proteinogenic, you could think about that as protein building. So, creatine is a non proteinogenic amino acid. So, it's an amino acid, yes, but it's not involved or integrated into proteins. Now, creatine is, however, synthesized, it can be synthesized in your body. And whenever it is synthesized from three different proteinogenic amino acids. So cysteine, glycine, and arginine are all involved in the synthesis of creatine. Now, typically people will take creatine as they get like a scoop of it and they add it to a shaker bottle and drink it that way, or add it to a smoothie. And sometimes creatine is actually found in energy drinks. I think REIGN is one instance where creatine is going to be found. Now, what creatine does is it helps produce energy during high intensity activities. People can synthesize it, and they can get it from their diet. Now, what I want to cover in today's lecture is I want you to understand a little bit about the biosynthesis of creatine and the systems or organs that are involved. I want you to also think about and understand, how does creatine support ATP production? So ATP is your kind of energy currency. Well, how does creatine play into that? Then, how does creatine impact exercise performance? What are standard dosages of creatine? The non-health, so kind of the non like bodybuilding and weightlifting health impacts of creatine, some misconceptions about creatine, and maybe we'll get into some creatine products. Now, typically, where does creatine come from? Outside of it being a dietary supplement, some of the places that you'll find creatine is you'll find it in meats. Now, with that in mind, um, if you were to have 100 grams of beef, and just to put that into perspective, 1 pound is 400, didn't turn out very well, 454 grams. So if you were to, let's say, get a 1 pound burger. So I'm going to take this 100 grams. I'd multiply that by 4.5. So then I multiply this by 4.5. And that's going to give me something like 1.8 grams. So if I ate a 1 pound beef burger, about 1.8 grams of that would be creatine. Now, it's pretty standard whenever people are like taking creatine for kind of a performance supplement, they take at least about 5 grams in a serving. And, it's pretty common. We'll get into this in a little while, that they take a total of about 20 grams of creatine over the course of the day. Now, where does creatine come from outside of meat sources? Well, it comes from your liver, your kidneys, and your pancreas. These all work together to give you creatine. Now, I want to draw your attention to this figure right here. This captures everything that is involved in creatine synthesis. Now, if we look at the top here, we've got the kidney and the liver. And we've actually talked about the kidney and liver and their function previously in vitamin D. If you remember vitamin D, the form that you ingest as like a dietary supplement, or the form that is produced from that UV light exposure, well, that has to be metabolized by both the liver and the kidney after that. Now, the steps that are involved in creatine synthesis, well, like I said previously, the amino acid glycine and the amino acid arginine are both involved in the synthesis of creatine. So these two amino acids come together in the kidneys to make a molecule known as guanidinoacetate or GAA. So a building block of creatine is made in the kidneys and that goes to the liver. It goes through the bloodstream to the liver. Now that molecule is going to have a reaction or it's going to be acted upon to actually make your creatine. So, thinking about exam sorts of questions, you could think about this as first step of creatine, and I'm going to label this as BS, but what I mean is biosynthesis. Well, what organ is that in? Well, that's in the kidneys. Second step would be in the liver. Okay. Now, that creatine, once it's in the liver, it's going to make its way to the bloodstream. And whenever it is in the bloodstream, it's going to be transported to a bunch of different tissues, including including muscle cells. And that creatine in the tissues, what it's going to do is it's going to take this form of, we're just going to simply refer to this as CR or our creatine. Now, this creatine, and what I want you guys to focus on is it's basically going to go into two different forms, creatine and phosphocreatine. So that right there is creatine. This right here is phosphocreatine. Now, these are kind of all of the different components that play into that. There's an enzyme known as creatine kinase. That's what CK stands for. CK is creatine kinase. Now, that's a pretty important enzyme. What I want you to know is that that creatine kinase takes creatine and makes phosphocreatine. Likewise, it makes phosphocreatine turn into creatine. So CK, creatine kinase, takes this, makes this, and it takes this and makes this. So it just kind of goes back and forth. That's what creatine kinase does. Now, in addition to that, all of creatine's kind of function is it's really trying to support and prop up ATP stores. Because if you think about everything that's going on in your body, well, it's ATP that doesn't. ATP is your energy currency. Now, that ATP or adenosine triphosphate it's going to take a phosphate group from ATP and put it onto something so that you can break a molecule down. You can extract energy from it. And I've always heard this kind of described as, if you decide that you're going to go out sprint, you're going to, sprint to the end of your driveway or something like that, or sprint to your car from your apartment. When you do that, the energy that you're using up very quickly is ATP, free ATP that's available in your cells. So think about this as ATP is your first E store, energy store. TCR or phosphocreatine is basically your second store. Because what that is going to do is it's going to basically fill in ATP by transferring a phosphate group from phosphocreatine onto adenosine diphosphate or ADP to prop up, like I said, and fill up the tank of ATP. So that's what creatine and creatine phosphate do. They're basically just to, fill in where ATP stores get depleted. Now, so what I want you to think about is, I want you to think about this right here. And I want you to know kind of what creatine's doing. You're making phosphocreatine so that you can make ATP. So phosphocreatine, arguably between creatine and phosphocreatine, phosphocreatine is kind of the more important one because of the fact that what phosphocreatine is going to do is it's going to help you fill up with ATP as you deplete it. So again, with using that analogy of if you're going to sprint from your apartment to your car, okay, you're going to use up ATP. Now let's imagine that you get to your car and you're like, oh no, I have to sprint to the mailbox. Well, your ATP, and this is it's your body's going to do very complicated things in order to like make sure that you're staying upright and everything like that. But imagine that ATP has been nearly used up. What you're going to then lean on is refilling that ATP. So think about it as from the apartment to the car, you use up your ATP. Can you still sprint beyond that? Yeah, you're going to slow down a little bit. You're definitely going to have some fatigue kick in, but that is where that phosphocreatine system is going to be kind of helping you out. So think about that as basically the progression, the sequence of things that are taking place. So I want you to know this. First energy store, ATP. Second energy store, phosphocreatine. After that, that's when you're going to start breaking down sugars. After you break down a bunch of sugars, like free sugars, free glucose, then you'll start breaking down things like glycogen. And then after that, you might start breaking down fats or proteins. Um, those are energy stores that you get into if you decide that you're going to run a marathon or something like that. Well, you're going to run that marathon and you're going to deplete your ATP, you're going to deplete your phosphocreatine, and then after you deplete your phosphocreatine, then you're going to kind of dip into your sugars, and then after your sugars, you're going to dip into proteins, and then after proteins, you're going to dip into fats. But what I want you guys to know is first ATP, second phosphocreatine. Okay, now creatine, like I said previously, is pretty heavily involved in it is a very well studied dietary supplement and compound for exercise performance. Now, I found this paper that investigated, this brings up dosages, but it investigated the role of creatine and performance, like weightlifting performance. And this paper was published, I think it was in 2019. I think it was this one. Yeah, yeah. And they gave a little bit of history. One was that creatine was isolated and extracted from animal muscle as far back as 1832. That's pretty wild. Now, with that, it really kind of gained a lot of kind of popularity and significance in the 90s. And since then, it is a dietary supplement that has sales that exceed $400 million annually. So this is a big deal. Lots of people use this. Now, I found this other paper. So what I want you to take away from this is kind of those timelines. Like it's been a big deal since the 90s, and hundreds of $1 million are spent on creatine every year. Now, I found this other paper that investigated the role of creatine and how it impacts different activities. Now, what I want to get into with this is that, well, first of all, there's there's lots of different proposed benefits of creatine. Sprints, for instance, um, weight lifts, work capacity, so your ability to, continue a high intensity activity for a long period of time, and the ability to recover from an exercise or from an activity pretty quickly. Now, in this paper, what they did was they looked at all of these different papers and they said, okay, well, in this paper, what was reported? So this is what's known as a review article. So they were reflecting on, well, in this paper right here, what did they look at? Well, they looked at 34 untrained males. And the question was, how long did they look at what they were doing? For 10 days. For 10 days, they studied these individuals and they gave them a dosing protocol where they said, take 20 grams of creatine every day. And what we are going to investigate is after that time frame, well, how does your ability to do a bench press or squat or any sort of weightlifting change? So that's what they did in this paper. In this other paper, they looked at, well, 19 trained males over the course of 12 weeks. And then what they did was they used a different dosing protocol, 25 grams a day for 7 days, and then 50 grams a day for 21 days. And then what they did was they used a different dosing protocol, 25 grams a day for 7 days, and then 50 grams a day for 21 days. And then what they did was they used a different dosing protocol, 25 and then 5 grams a day for the remaining 11 weeks. Now, I bring this up because well, what they saw was that people's fat free, or the people that were studied in this, their fat free body mass increased, their bench press increased, their squat increased. So all of these things were kind of conclusions that were drawn. Now, what I want to stress to you guys is the dosages. Oh, please, dosages. All of the studies that were included in this were basically as few as 5 grams, all the way up to 25 grams of creatine per day. So these are pretty standard uh, amounts, 5 grams or as much as 25 grams. And sometimes when people use 25 grams, they use what's called a loading phase. And so that's what was highlighted right here. They did a loading phase where they used a lot of creatine. And then after that, they reduced the amount that they were including. Now, lots of things that came out of this was that the trained athletes typically benefit more from an untrained athlete. However, untrained athletes who were supplemented with creatine saw a 20 to 25% increase in muscular strength. And this was while undergoing a 10-week concurrent strength training. So basically, creatine plus strength training protocol saw an increase in strength. Now, your dosages, like I said, what is this? Okay, so it's pretty typical for your dosages to be as much as, like I said, 25 grams a day in this sort of loading phase. Now, the timing of this, well, I feel like I should have figures here. Know what happened to my feet? Oh, that's strange. Okay, yeah, there we go. Oh, my pictures. Um, Sorry about that. I got it figured out now. Now, creatine is a very well studied dietary supplement, and it is something that the scientific community has kind of, in the exercise sports community, and chemists and biochemists have kind of embraced in terms of what it can do. And it's well studied with respect to like what's a dosing protocol, what's the amount to take, and what happens to it in your body. Now, with that, there's also tons and tons of YouTubers and influencers. If you look them up, you're going to find, well, here's exactly what to do. And, you know, there's lots of clickbait sorts of things like this, where it's like, oh my gosh, this insane result. Oh my gosh, how could this have possibly happened? And more than likely, these people they're branding and they're trying to sell something. That's probably what's happened with this. Now, creatine supplementation, like I said, dosages of 20 to 25 grams per day isn't that radical an idea. That's typically your loading phase. And then after that, a smaller dosage is typical of kind of a maintenance phase. Now, the protocols in terms of who takes a certain amount and everything like that, that varies from study to study that I looked through. Now, the timing of creatine, well, that could also be something that's worth investigating. Um, Several factors can modify this, like when is the right time to take it? Take it before or after a workout. And, I found this paper right here, which provided this figure that said basically, what do we know? Well, for one, creatine supplementation increases your total creatine content and your exercise performance. It's really not negotiable. That's what all the data says. Now, several factors can modify this, including your age, your diet, and your exercise. So essentially, if you're not really caring about what you're eating, maybe this creatine has a little bit less of an effect on you. Now, what we also know is that supplementation close to exercise, so that's like before or after, appears to be superior in enhancing total creatine content compared to when supplementation is far from that exercise. So things that we don't necessarily know about creatine is, well, how much does, is there a benefit to be taking before your activity or after your activity? Does it even really matter? And that's something that remains at this point kind of, I guess you could say, unsolved. Now, with that in mind, does creatine have any sort of benefit to non-exercise related activities? And so this paper was a review article that investigated the role of creatine on brain function and overall health. Now, the vast majority of research involving this is focused on skeletal muscle. That's what, typically people are taking it for. However, question remains, does this actually benefit like cognitive abilities? And the purpose of this study was to summarize basically what's out there regarding this. And what the authors of this paper kind of concluded was that this GAA, which is one of those intermediates in the metabolism of it, um, is that, sorry, the impact of creatine on cognition with a focus on sleep deprivation. They discussed the effects of creatine supplementation, a variety of neurological and mental health conditions, and outlined recent advances on creatine supplementation. So they were just kind of giving like, what's the latest? And so, they kind of concluded in this paper that there's still lots of work that needs to be done, and anything that is about creatine and brain function, it needs to be developed a little bit more. Now, there are quite a few misconceptions. Now, I have a friend who he had a heart condition, and he says he it's because he took creatine. And I think that is something that remains I don't know if I would say a sort of boogeyman, but it is definitely a kind of reputation that creatine has, which I think is probably might have to do more with the manufacturers of the dietary supplement. Now, creatine is one of the most popular and well-studied supplements, and basically this is what it's doing. This is kind of what I was alluding to previously. Creatine right here feeds into phosphocreatine. Phosphocreatine feeds into your ATP supplies. Now, there's still some misconceptions that, creatine's like a steroid. It's not. This is what it is right here. Know this creatine cycle, what it's doing, the sequence of this cycle. Um, that's what's important for you guys to know. But are there maybe some people who should and other people who should not be taking creatine? More than likely, yes. But this is kind of a misconception. But now, many of the misconceptions or many of the opinions of creatine is that it causes kidney and liver damage. Well, the metabolism of creatine relies on your kidney and your liver functioning. It could cause gastrointestinal issues, so GI issues. It might have diarrhea or something like that. And then one other kind of myth is that it leads to weight gain. That if you take creatine, well, you're going to take on a lot of water, and that's probably anecdotally true. Um, that's what people will say. However, the data that I looked at and the papers that I looked at kind of dismissed that as a really a possibility. And if you're gaining weight, it's certainly not fat. Now, with that said, here's the last kind of I guess infographic about creatine, and this is provided by the Uniformed Services University. And this says that approximately 3 grams per day is like a safe dosage. So basically, as low as oopsies, as low as 3 grams a day, all the way up to 25 grams a day is kind of your dosage range, your most common dosage range of creatine. Okay, well, I hope that was helpful, and I hope that you have a good one. And remember that creatine cycle, because that sort of thing's definitely going to be on the test. But also look at the review doc that I posted on Sunday for maybe some more information and guidance about what's on your exam. All right, everyone, have a good day.